Yeah, g'day guys, and welcome back to my channel. After I got the electrics working and the hydraulic drive of my table working on my Jones and Shipman surface grinder, those main spindle bearings sound awful. I figured this week I'd pull the spindle apart, either replace or grease the bearings, and have it up and running again. Instead it turned out to be a bit of a rabbit hole of making special tools or making up some screws, so I'm still not quite finished with it, which is kind of a shame because the weather's looking fantastic and I'd really like to be back out in the garden doing some more castings on my replica motorbike engine project. Since these bearings sound terrible, I'm going to need to remove the spindle and it needs this out of the way. So I need to make up some sort of a little special tool. First to undo this nut inside and then probably also to press this off the taper. First let's make the nut tool. I got this bit of water pipe, looks like it's about the right size, so I'll just make a couple of tabs in that. Thin those down a little. Given how rusty this all is, I would not be at all surprised if the ears just break off my new tool and I get to make another one. I'm guessing this is a left-hand thread. Oh, nice. Wasn't over tight. Cool. Now to pop this off its taper, there are two different kinds of wheel hubs. Some of them use the outside thread, which also mounts the grinding wheel nut. Some of them have threads up in here and you need an internal puller. So I don't think there's a thread inside there, is there? No, all of mine are this style. I need a tool which threads onto this outside portion here and push against there. Right, to make the puller, I couldn't find a decent piece of bar stock, so I think I'll just fabricate it out of a bit of tube and two end caps. It ends up hollow anyway, so that should work fine. But they say TIG welding's somewhat sensitive to gaps and stuff, so let me just first straighten up this cut. Right, it's always a bit of a challenge turning the rough stock round. I think the easiest way to do it this time is just going to be to put a couple of tacks on it, put it back in the lathe to remove all those bumps on it, and then once the bumps are gone, it should be easy to get a nice even weld all around. Right, let's crank up the arc captain. Okay, DC TIG, I'm using my foot pedal, no pulsing, that all looks fine. Alright, now I can go and turn down the first lumpy bits. Well, I should probably stop here because those two welds look great. Well, I think I put way too much heat into that, but it's certainly not going to break. Right, well, I think that works so well, I'll just repeat it on this side. Okay, so I went over and quickly turned off the lumps again. Still need to learn how to finish a weld properly because I keep getting those like sticking out bits at the end of each weld. To make this work as a puller to pull this off the spindle shaft, it's going to need that thread in it, and that thread is 1 1/4 by 20 TPI. To cut the thread, this was just an old carbide end mill shank, which I ground 55-degree flanks on. This is going to be a Whitworth thread. I'm putting in a boring bar that was, as with many of my tools, a gift from Malta. Thanks, Luke. Of course, the other thing to note before I cut this thread is that it's a left-hand thread, so I'll be feeding outwards away from the chuck. Now, one of the cool things about the lathe macros from Andy Pugh is the metric imperial widget, which he built right into it. Here we want 20 TPI, so 1.27 millimeters, and we need to go out to 1.250. 31.75. Okay, so what have we got? We've got tool number 81. Wow, first time lucky. Look at that, goes on perfectly. I've also got a second hub here, second spare. Let's see if it works on that as well. Nice. Okay, so I think we're ready to go and try and pull the main hub off the machine. Let's have a look. Nice. And that was all there was to it. It's a bit rusty on that taper, that's not a good sign. With that now off this side of the spindle, I need to turn the machine around and take the pulley off the back side. Okay, so spindle and motor. Oh yeah, they just pop off. That's good. Nice little sheet metal covers. What are we seeing here? Belt, at first glance, looks pretty dirty. We've got a fair bit of rust on the pulley. The run out doesn't look obviously terrible. Moving down, the lead screw to raise and lower the head is under this metal cover, which should keep it somewhat protected. It's got an oiler on top of it, so I'll just lower the head down so I can get to that oiler and fill that. My lord, that's slow. Let's plug it in. Do it electrically. Wonder when the last time was that this thing got some oil. Either the oiler is blocked at the top, or maybe it's got a felt or something that needs to work its way through. Bit of surface rust on that cover as well. Pretty much just wipes off. Down here is an end stop for the electrical switching. I might just try that out. Okay, now that's the up stop and it's working. Good. It looks like the belt tension adjustment is off these blocks here, so I'm wondering whether I need to remove this thing first, because it should just be a cover. Does it pop off, or I guess I need to come up a foot higher to remove it. Someone's put grease on it instead of oil, although maybe not such a big deal with a slow moving screw like that. That's probably not even a problem, but I'll give it a clean up anyway. Oh, I just noticed another lubrication point I missed. Okay, at this stage I don't want to take the motor out. I just want to slacken up that belt. So I guess I need to lift it up. This looks like this counter nut was already loose. It's getting looser. Okay. Okay, the belt is perishing and falling apart, so it looks like I'm going to need a new belt. Now, if you've seen Bart's videos on his 540 surface grinder, you know that he had a bent motor shaft on his one. Just optically, this looks fine, but I'll put a clock on it and you can just see whether it is running straight. The motor itself is rubber mounted, so any pressure on it just looks like run out, but it's really not. Okay, that looks fine, huh? Within a hundredths of a millimeter, great. And the motor bearings, what do they sound like? Don't sound too bad. What about under power? Wow, without this friction of a belt, this thing spins forever. At some stage, I'm sure I'll get to the motor and then I'll grease its bearings as well. Judging by the hole in the casting, it looks like this pulley doesn't have to come off now. I should be able to pull the whole spindle with the pulley attached. Then it should be easier for me to get some opposing force on it to unscrew and stuff. So that means, first off, I'll come around the other side and I'll just start by pulling this cover off. It's good to get that off because it's got a dent in it anyway. I thought it was two different way covers because I saw that line there, but it turns out that's just bad painting. Nice little telescoping cover there, which does help to keep some of the dust out at least. And up here's another telescoping cover. The top of the spindle housing here is kind of a mounting flange for various different accessories, radius dressing attachments and stuff like that to give you different profiles on your grinding wheels. Obviously I got none of those accessories with it. So this lower cover overlaps the upper one. Right, before I start removing that spindle, I'll just put a block under it to give it some support so it doesn't fall down. Doesn't sound that healthy, does it? Okay, so it obviously doesn't like going all the way down. It sure looks like the eccentric adjusters, which put the pressure on this vertical sliding casting, are probably out of adjustment. Huh? Oh, that's a heavy beast. First up, I'll just get this vacuum attachment out of the way if I can. Okay, all three of those were barely finger tight. I'm really not so pleased to see these stainless steel countersunk socket head cap screws because they really don't look original. Anyway, let's try getting this pulley off. Now the hardest bit here is probably going to be getting opposing torque. I don't think I've got a strap clamp. That would be perfect just to strap on there, but the other one was pretty loose, so let's see if this one is as well. Right, I went searching and I found this strap clamp, which is spring steel by the looks, and I don't want it scratching up my pulley. First I'll just degrease that and then put a layer of tape over it to protect it. First I'll put some gloves on. Okay, so far I just broke my high quality tool. Since it's a bit rusty, I'm just going to put a bit of heat on there. So I'll just shorten those arms a little. As is often the case with this sort of job, first you try the sort of minimal methods and then you get escalation until it works. So clamping it down to the table, I can stop rotation automatically. So now I can push down with both hands on this and it'll immediately break free. In fact, I can probably even make a little bit of an extension bar if I need to. At this stage, it's just going to bend. So I need to make a new one of those. That one's too weak. Okay, well, since galvanized water pipe is obviously made of high quality tool steel, although this one failed, there's no reason why an almost identical one won't work perfectly. Like this. One of the good things about water pipe is it's really good as a torque extender. Okay, so what I've proven so far is that nut is pretty tight. Right, well, since the first pulley removal tool I made failed miserably, I made a second one exactly the same, which failed exactly the same. Who would have thought? So I was going to make my own removal tool out of some better steel, maybe even heat treat it. Mail time. When this package came in from Tim from California. Now I was chatting to Tim last week and he said he had a same sort of surface grinder and had a few like spares and leftovers and stuff, so really appreciate this. So these are some sort of This one got chipped. Some sort of very, very fine, like cutting discs, I guess. Unfortunately, one got damaged in postage. The rest all look pretty good. There's a couple of spacer discs, maybe. Not sure what those are going to be used for. These discs go between the grinding wheel and a hub. Oh look, he's even given me an extra hub. Thanks very much. This is one of the ones with an internal thread to pull it off the taper. These are the cardboard blotters that you put up against the wheels. They're supposedly quite important for preventing damage to the wheels, I guess. There's no threads in that, so I'm guessing that's just some sort of spacer. Aha! A spare or replacement wheel nut. That's definitely going to be handy because the one I've got looks pretty heavily worn already. Oh, this looks like it's a pair of dressing diamonds. Brilliant, thanks very much. And last and definitely not least, ta-da! The tool I need to remove that pulley. So, thank you very much, Tim. Really appreciate your generosity. That's brilliant, mate. Right, just a quick sanity check before I start trying to undo that nut again. Needs to rotate in this direction to rise up off that thread. Unfortunately, the top end of the tool's two spiky bits that I've got to push against, so just try and bury that in some rag. I want to get a really nice even pressure on it, and then I have this the bottom just twisting. Oh, there we go. That's got it. Thanks a lot, Tim. Brilliant. So now I can also use my homemade puller. And there we go. Now here on the grinding disc side, I've got these three stainless steel screws, and zooming in you can see that marking A2, and the reason they worry me is because this is supposed to be an imperial machine, but that's too small. But that doesn't fit from my inch-based set. So if we switch over to metric, sure enough, it sure looks like somebody's replaced these fasteners with badly fitting metric fasteners. Not cool. Not cool at all. God, they don't look like they even come close to fitting. So I'm going to guess that the correct fasteners are the same as the ones on the back side, which would be those ones. Yep, so original and jammed in the hole. Okay, so 188 is 3/16. Taking the crests off the threads, yeah, this is a 3/16 screw. My imperial tooth gauge has only got 28 and 20 tooth gauges, and this thread is coarser than 28 but finer than 20, so that would make sense because 3/16 Whitworth should be 24 TPI. 24 TPI is just over 1 millimeter pitch, but M5 is a 0.8 millimeter pitch, so that's like a 20% pitch error that somebody's forced
to make this fit into the hole for this.
Man, didn't they learn the whole game with the triangle things and the triangle holes and the round things and the round holes? Well, there was still grease there. That's generally a good sign. Now, I've no idea what grease Jones and Shipman specified for these bearings, but this kind of looks like a cheap chassis grease that's got old. That is a lot of grease for a precision spindle. On the one hand, it's good because it keeps corrosion out, but that is not normally the way you would grease a spindle like this. So here you can see the spring loading between the two parts of the spindle cartridge. That's what preloads the bearings. Pop that out. I briefly tried putting those springs back in, but then I just removed them. It's all getting disassembled anyway. So I've got 3 holes in here and 3 holes in there. There was nothing in there before. Those holes are threaded. So I need a Whitworth screw with about a 210 thou minor diameter, which is 1/4 inch British standard fine. So I'm assuming there's 3 more lost fasteners here, which locate this and would also stop crap from getting in there. And those need to be about 1 inch, including the cap head, which is probably 1/4 inch. So I'm guessing the thread length is going to be 3/4. Those of you who are big fans of this Whitworth system, are you also fans of them jumping between coarse and fine all the time? Okay, next thing I just noticed on this spindle cartridge is this keyway, but I didn't see any key coming out. But if we look down the housing, see that? What is that? It's also been completely caked in with that horrible paint. Well, it sure looks to me like it's supposed to have a pin on the end of it, and it's been broken off. So I guess I'll have to make another one of those. Right, to continue disassembly, I'm going to need a pin spanner, and it needs to be... Well, I had to go and drop off some stuff at a mate's place, and since he's got a nice arbor press and also a pin spanner, I just took this with me and disassembled it there. Let's take a quick look at these bearings. Okay, so as expected, the bearing sizes, it's called a VL206, but it's the same as a modern 7206, with this one being a 7205. It sure looks like they were heavily over-greased, and also the way the grease has aged, it looks like it's not a very high quality grease. So first I'm going to do is just wash them out. You can see there's some marks on this outer race which show that it's probably spun. I'm wondering if I've got the same issue with this spindle as I had with my Mahu spindle, because on the Mahu spindle I had a crash which elongated the bearing retainer screws, causing it to lose preload. Whereas on this, one of the caps had those metric screws which may not have been torqued down properly, and the loss of preload allowed the bearing to spin. Anyway, I will clean them and see what they look like before I decide whether to just re-grease them and retry them or to replace them. Now when I did the bearings of the Mahu, to clean them I used some white spirits in a jar in the ultrasonic cleaner, and there was a lot of people who screamed at me, you can't put bearings in an ultrasonic cleaner because the vibrations dent the balls and dent the races. And I came back with, well, there's procedures for ultrasonic cleaning of bearings published by GE and Rolls-Royce, so I'm not sure it is such an absolute no-go. But based on that, I had a discussion online with Andre. What he did is he took 2 brand new bearings, cut one up straight away, cleaned the second bearing in an ultrasonic cleaner like mine, then cut it up and inspected both of them under the scanning electron microscope and sent me the results. So as you can see, even a pretty low powered ultrasonic cleaner looks like it does definitely cause some problems. So I won't be doing this with the ultrasonic, and yeah, thanks a lot to Andre for providing that data. Well, I figured if I'm gonna clean out these bearings, re-grease them, put them back in, I'm probably not going to be disassembling it again, so I better paint this at the same time. I know, it's kind of feature creep for this project. Somewhere in the last couple of weeks, along with the unproductive procrastination, I did manage to do a bit of productive stuff as well, such as cleaning all the schmoo out from between the T-slots and stoning the table and stuff. And I also pulled off the guide rail and the stop block assemblies and gave all that a good clean up. So I need to screw those back on. And I did the same for the end stops which bolt here on the side for the cross travel. Now there's plenty of things I'd rather be doing right now than making a few little screws, but since Brexit, it's really hard to get British standard hardware over here on the continent. There are eBay shops that will sell you this stuff, but then you look and they won't ship to Europe. There was a couple of kind people like Andy Pugh who offered that if I bought them via eBay UK, he would then ship them on to me, but this just gets ridiculously expensive. You end up with 6 little screws ending up sort of 30 plus euro. So yeah, you know where this is going. Well, if I'm going to make these things, first I'm going to need a hex. Okay, there's a quick sketch up of the first screw that I need. So I'll start by making this 2.6mm hex, and I'm going to make that out of 10mm silver steel. I think you call this O1 oil hardening steel in the States, something like that. Right, and for the second set of screws I need this 5.3mm hex. Right, well that's my 2 blanks done. They're now ready for heat treatment. This stuff just protects the surface of the metal from corroding while it's getting heat treated. Hey, just before, did I call this oil hardening? It's actually water hardening. This one won't take as long, I only really need the tip hardened. That's glass hard, as is that one. Just quickly clean this up, ready for tempering. You need to do this so you can see the oxide colour, which gives you an indication of temperature. So here I'm going to put the flame on the body and just watch the oxide temperature as it rises. And once this gets to like a straw colour, I'll quench it. And there we go. That's a nice straw colour. Hopefully there you can see that light straw colour in comparison to a piece of blank steel. Oh shit. Oh darn. Don't put front heavy things in a vise and then open them without support. Ouch. That wheel looks pretty dead. Okay, so I've swapped that out for an undamaged wheel. I'll just need to be more careful when I index this each time. Right, the steel I'm going to use for making these screws is 42 chrome moly 4. Well, since I don't have any better gauge than just the actual part, let's try that out. Well, that feels like a really nice fit. It's not loose or anything, but it goes on smoothly. I'll call that a success. To do the heads, I found it faster to switch out the parts each time. I've made that mistake before. That is being in feed per revolution mode and doing a feed rate in feed per millimeters. So in this case, I gave it a feed rate of 50 millimeters per minute, and instead it interpreted that as 50 millimeters per revolution. So yeah, that was kind of a bit too fast. Okay, that wasn't supposed to happen. Well, I was obviously a bit stingy on the back rake when I ground this one. Once again, seeing as this is the only part I've got with this thread, I'll use that as a puller. Also not ideal, but hey. Probably made that driving hex a little bit too small. It's quite a firm fit, but it looks like it is going to work. Broaching those heads was the last operation on the quarter BSF screws. So next up I need to make the little British standard Whitworth 3/16 screws. Now I've done a bit of playing with this, and instead of using the rotary broach to make the hex, because it's so little, it seems to work better just to beat it in. Yep, that'll do it. Right, with that done, we can turn all the external features on the screw. Okay, so that's an original. And that's the one I've made. So now it's just rinse and repeat. I need 2 more. Since I made these out of chromoly steel, heat treating them is probably not necessary, but I'll do it anyway. I'll just put my mask on because I'm using just some of the ceramic fiber stuff. Now to temper them, I don't want these screws to be too hard, so I'm going to temper them back to maybe blue. It's going to be hard to nail it exactly. I'd rather they be a little bit too soft than a little bit too brittle. Starting to go. That was okay. And right, well, just to dolly them up, I'll hide my poor preparation and inconsistent heat bluing with some of this stuff. Leave a link below. This is going kind of blotchy. Maybe I should have polished them first. Really doesn't look like it improves on the heat bluing, does it? I'm not sure how well these chemicals work on some of these higher strength tool steels that have got a fair bit of chrome in them. Right, I gave them a quick rinse off. Now just a bit of oil on them and they'll be ready for use. Okay, so that's my 6 missing screws made. Now there's also that anti-rotation pin which had the tip broken off, and looking at it, it's so long, I guess all I need to do is just turn a new pin on the end of it, because there's no need for this length of screw thread. It'll just screw in a bit deeper. Now I know you're not supposed to clamp onto threads, but don't tell anyone, okay? So the slot is 1/8 of an inch, so with a wee bit of clearance, I'll aim for sort of 3.1 millimeters. Okay, that's good. Roughly once a month for my Patreons and YouTube members, I do a live stream. So I'll do the next one at 9 o'clock in the evening, Central European time on the 13th. If you're enjoying my channel and like to support it, I'd really appreciate it. Come and join me. Okay, with those parts now complete, clean and ready to go, I still need to finish paint stripping my spindle housing and then prep and paint it. It's going to be difficult to slop paint on this badly enough to match the vibe of the rest of the machine, but I'll do my best. Now I've run out of time, so I think we'll talk spindle bearings next week. Thanks very much for watching.